Hello and welcome back to the Cracking Fang YouTube channel. Today we're solving Leetcode's daily problem 1684, count the number of consistent strings. You are given a string allowed consisting of distinct characters and an array of words, strings words. A string is consistent if all the characters in the string appear in the string allowed. Return the number of consistent strings in the array words. So basically, very simple problem. We have our allowed characters, we have some words, and we just want to return the strings in words where they are only made up of the characters, I guess in this case, A and B. So as you can see, obviously AD doesn't have a B in there, so we can't use it. BD doesn't have an A. AAAB does, so we can have that as an answer. We can also have BAA, and then BADAB doesn't work because there's no D in allowed. So the only two allowed ones would be these two, and we'd return 2. So really straightforward. Obviously this problem is an easy one. There's not really any kind of like hardcore data structures we need to use. All we're basically going to do is just check for each word, does it contain, are all the characters in the allowed strings or the allowed characters? If yes, then we increment our count. If no, we move on to the next word. Nothing like fancy here. You can do it in multiple ways, but all the time complexities end up being the same, because if you actually look at the constraint here, it's only going to contain lowercase English characters, so your time complexity and space complexity are going to be very small because of that. Okay, so let's just code this up. No need to kind of go through any kind of walkthrough of examples. It's pretty straightforward. First thing we want to do is we don't want to be searching through a string because that's going to increase our time complexity. So we're actually just going to use a set here. So we're going to just say allowed characters is going to be equal to a set of allowed. So this will basically just take every element in allowed and make a set out of it. Then we want our result. Obviously it's 0 in the beginning. Then we're going to check each of the words. So we're going to say for word in words. Word in words. We're going to say if, and we're going to use a Python function here called all. Essentially what this does is if all of the elements inside of a list are true, then it will return true, otherwise false. So basically it's just some syntactic sugar to save us from writing some extra code. So we're going to say if all, so char in allowed chars for char in word. So basically for each character in the word, if that character is in allowed characters, we're going to return true. Otherwise, we're going to return false. This is going to create basically a comprehension here, and then all will check whether or not every single element is true. If it's true, then that means that we have a consistent string. Otherwise, we just continue and we don't need to increment our result. So if we have a consistent string, if all of the characters in our word are in allowed chars, then we increment our result by 1. Otherwise, we just move on to the next word. Cool. So we can, at the end of this, just simply return our result. Okay, let's run this, submit it, and it should be accepted. Okay, oops, what happened there? Time and space complexity, for those of you that care. Basically, let's see, the time complexity. Obviously, we need to create our allowed chars here. So this is going to take big O of, let's call it A, where A is the length of allowed chars. And then we have what? So we're going to go over all the words in words. So that's going to be big O of N. And then what do we need to do? We basically need to check every single character here. So that's going to take, let's call it big O of K. Oops, big O of K. And what is all of these variables? So A equals to number of characters in allowed, N equals num words, and K equals length of the longest word. So in this case, you can actually consider this as just being big O of 1, because we know that the number of characters is capped at 26. We only have lowercase English characters. Therefore, we don't actually have to worry about anything here. We can just say, okay, well, we're not doing you know, we only have constant space. We know it up front. So really, you can think of this as kind of going away asymptotically. For the space complexity, it's going to be big O of A. But again, asymptotically, this is just big O of 1 because the problem constrains us to saying that actually, how do I get rid of this? Okay, whatever. The problem tells us that we only have lowercase English characters. So that's how you solve the daily problem. Super straightforward, super easy. Probably most of you won't even watch this video because it's so straightforward, but whatever. I just want to make the daily video every day. If you enjoy the video, leave a like and a comment. Helps me grow the channel. Subscribe, and I will see you in the next one. Goodbye.